Hello, this is the second part in the bone editing tutorial, and now we're going to show you how to add bones to an object and how they deform an object. So I have a very simple object here that I created in Modeler, just a tube that I extruded and subpatched, and then we'll add that by hitting the plus key. Find the object. There it is. I like to spin this default light so I can get a better view. Okay, so with the object selected, remember bones can only be part of an object. They can't be something else. Let's go to the Setup tab and add a bone. Okay, now we can see it. It's a bit hard to see, and when we select something else, we can't see the bone at all. So the way to see through the bones through the object, which you definitely need to do since the bones need to be sort of in the center of the mesh, is go up under the View tab and go to Bone X-Ray. And now you can see the bone much better. So let's move the bone down here, and then I'll hit Shift R to change the rest length. I'll move it out to the encompass the entire mesh. I'll go to Bone Split, and I will make 3 bones here. Okay. So now we've got bones and we can move them, but they're not doing anything to the mesh yet. What you need to do is select one of the bones, and with the middle mouse button held down, you're kind of in bone selection mode here. With the middle mouse you can drag out, and you can select all the bones. It will only select the bones. It won't, as you can see, it's not selecting the light or anything else, not selecting the object. So if you hit R now, all the bones that are selected will activate. You don't see any changes in the mesh because the bones have been placed very neatly down the center of the mesh. But if we start to move it, you will see that it is actually deforming this object. Okay. And so now we get into the options where we start to deform the mesh with the bone. If you bring this up, you will see that there's actually quite a few different options here for deforming the mesh. And I don't know all of them very well, but I'll give you a basic rundown. As you can see, when you spin your bone, when you rotate your bone, it's going to start crimping the mesh. Let's say you were doing like a bicep or something. Well, you could start turning these options on, and as you can see, the various functions of these will go ahead and take place. And what they are, basically, joint compensation will just basically smooth this out so it doesn't crimp quite as much. And the joint compensation for parent means that as the parent moves, sometimes it has an effect on the child bone, and this will alleviate some of that. As you can see, there's not as much crimping. It just basically adds the influence of, if there was another mini bone here, it kind of adds it. The muscle flexion, of course, as you spin it, and as you can see from the side view, the mesh is straight on the top edge, and as you spin it on the pitch, it bulges. So if you had a forearm or something like that, you would want to add that. This is a forearm, so it doesn't make that much sense to add that, so we'll turn it off. The muscle parent flexing will do the same thing to the parent, and as you can see, if this was an arm, and this was the forearm, and this was the bicep, you can see that it's starting to deform the parent and bulge out the parent. And so it's very useful for setting up like an arm or a leg or whatever. So that's the basics of that. Now I'm going to get into one of my pet peeves with rigging in Lightwave here, and you will notice that as you rotate this, these rotation handles will spin to the point where your bank and your heading are the same. They're on the same rotational plane. This is called Gimbal Lock. You can't rotate them anymore, and this causes really big problems when you're animating and when you're doing IK especially. So if you animate using this standard coordinate system, which is the parent coordinate system, you're going to get this problem with these things going out of whack. And it's because of the type of coordinate system that Lightwave uses. To me, it's a really big hassle, and I do something that I'm not supposed to do, apparently. At least the tutorials say not to do it. But as you can see, it's more difficult to see here because these things are all lined up correctly. But you can see in the parent coordinate system that all these rotational axes are separate from each other. They nicely look like that. But if we add one, and let's say, for example, we had to have this bone pointing in this direction at its rest position, you'll see that these rotational axes are kind of messed up now. And the way to get these things aligned correctly is to hit Shift P, which is the shift correction or pitch correction tool. And as you can see, when you do that, these axes line up correctly. Alright. Now when you animate it and move it around, the axes are still going to go out of line, but at least they start out in the right direction. And I'm going to add that, activate that bone there. So what you need to do here is, if you want to animate using this parent system, you're going to have to deal with these axes going out of whack like this. I don't do that. I actually go, after I've shift corrected, I hit Shift 7 and I go to the local coordinate system, because this to me makes more sense. As you'll see, when you're in the local system, the axes always stay with the bone and they never kind of go out of whack. So you can always get a good handle on where things are at, and to me this is the way it should be set up. The other system is the world system, which, as you can see, the axes don't spin at all. They just stay centered at the world coordinates. That one I don't use too much except for when I'm manipulating objects out in space. But the problem with using this coordinate system is the fact that if you don't pitch correct these things before you start using the local system and you go to animate, let's say you want to animate this thing rolling from its start position up like this. Well, in this case it's okay because I had pitch corrected, but let's see if one of these does it. Sometimes you'll get this to happen where we are kind of seeing it. You can see it, the effect here a bit. It's not that pronounced, but as you can see, instead of rolling straight up, it's kind of going off to the side and then going up. So what we need to do is correct these on their pitch. Shift P. And then we need to delete the animation for these. So like I said, it has to be done beforehand. Now let's see here. When we go to the local system and animate, it's going straight up. Instead, before it was kind of angling up. And you'll notice it very, very pronounced on certain setups. If you don't have it set up correctly and you animate in the local coordinate system, it's going to cause total chaos, because instead of it going directly the way you would expect it to go, the bone will flip around 360 degrees and then arrive at the same place, but it will have animated in a completely unpredictable fashion. So that's the basics of adding the bones and a little bit of a rant on how to use the pitch correction and what its use is.